students. Today we're going to start our study of a new chapter. We're going to start chapter 14, talking about surface area and volume. So we're moving from a two-dimensional world to 3 dimensions. So as I mentioned, we're going to start our study of chapter 14. In chapter 14, we're going to be talking about surface area and volume. When you think of surface area, you think of what's on the outside of something. So if I were trying to wrap this cylinder with paper, suppose it were a gift, I was going to cover it with paper. The surface area would be the amount of wrapping paper I need, so to speak, to cover the exterior. If you're thinking about volume of something, you think of how much is inside. So in that case, imagine I'm bringing a liquid into the cylinder, and the volume would be how much could it contain or hold, like liquid volume in milliliters or liters, so to speak. So if we're looking at recapturing our prior knowledge on these subjects, let me take you through a guided tour of some shapes and talk about the applications from a standpoint of surface area and volume. So we've got some figures here. On the left side of your screen, you're going to see a cylinder. On the right side of your screen, you're going to see a sphere. So identifying cylinders, spheres, and cones, you'll see a cone at the bottom in just a few minutes. So a cylinder has two circular, grab my highlighter and kind of break this thing down, read a little, do a little, has two circular two circular flat faces or bases. So they're right here. Here's base 1 and base 2. All right, so those are faces and bases. They're congruent and parallel. So this base is perfectly parallel to this base. So they kind of mirror each other, if that makes sense. And they're joined together by this curved surface right here. So that's a cylinder. When you think of a cylinder, you think of, let's say like a can of soda or something. So you're thinking of liquid that you could pour into it, right? You could store a certain amount of milliliters of liquid. The other thing I think of is like a can of, a can of soup. All right, so cylinder, and then on the right side we've got a sphere, which has a smooth curved surface, and it does not have any edges or vertices. So here's your picture of your sphere. It's the same distance across the center of the sphere from one point to the other. So from any one exterior point to the other portion of the sphere, directly opposite, it's that same distance. So you think of like a diameter of a circle as the distance across the center of the circle. When you think about a sphere, you think of like a basketball, a soccer ball. And what you have inside is usually air. You fill it with air. You could kind of think of a water balloon if you wanted to stick with the liquid measurement. But they have something called like PSI, which is pounds per square inch. How many pounds per square inch would be the volume of air? It's recommended that an inflatable ball goes. So if you put too much volume of air in there, what could happen? Yeah, well, I bet you said pop. That's what happens. So you think of volume, you think of what goes inside. if you think of surface area for these two figures, you would be thinking of, suppose they were a gift. Suppose you got your cousin a soccer ball as a gift for his birthday, loves soccer, and then you want to wrap it. The amount of wrapping paper that would go on the exterior of the ball would be the square inches, the surface area. All right. Or if you had something shrink wrapped and you put plastic around it and it shrunk to the size of the object, that would be the surface area of the shrink wrap. Inside would be the volume of air. Same thing here. If you're wrapping a gift, you would put paper on the outside. There's your surface area of paper you need. And if you're filling it with water or something liquid, then that's your volume. Okay, I may not have mentioned that cylinder has no edges or vertices. Let's take a look at this cone figure down here. It's got a vertex at the top. It's got a curved surface and another circular base. The cone has one circular flat surface or base and a curved surface, one vertex. Okay, so those are the three figures we're really going to be talking a lot about over the course of chapter 14 in the next few pages and exercises. The cylinder, the sphere, and the cone. Today's lesson is more of activating some prior knowledge, and we'll get you thinking a little bit more about volume. Let's hop ahead and look at a few more slides. So I was doing some practice teaching before I met with you guys today. So let me erase my notes. I'm going to give you about 30 seconds to read through this page yourself. Cold read. All right. So we're measuring capacity and volume. When you think of the word capacity, like what capacity do you have? What mental capacity do you guys have? You guys have huge mental capacity. You have the ability to maintain and to hold lots of information, particularly now with the closure. It's just blowing me away how much you guys are able to hang on to through this digital learning. And then the volume. We're not talking about the speakers on your earbuds or your Beats or your television. We're talking about the volume inside of a shape, such as a pitcher. And when you think about a pitcher, you think liquid volume. So let's suppose this is some apple juice, and you're making some kind of a recipe. And some units of measure for volume are liters and milliliters. So when it's a bigger container, you think liters. When it's a smaller container, you'd think milliliters. So I'm going to give you a quick energizer. Run over to your fridge or your garage or wherever you keep, your water bottles, or maybe a bottle of ketchup, barbecue sauce, mustard, steak sauce, something with liquid measurement that might have a measurement on the side label. So go ahead and grab 1, 2, or 3 of those bottles very carefully. Come on back and let's take a look at liters versus milliliters. So you probably noticed I also got changed from just that quick. No, actually, I filmed part of this yesterday, and then things got a little hectic around here, so I'm finishing the second part of this video today. So I grabbed 3 things with liquid measurement, different sizes. The first is my favorite, Frank's Red Sauce, Frank's Red Hot. This is not a commercial, by the way. No one else will be seeing this, but Radnor students. And if you can guess, milliliters or liters. It's 1.9 fluid ounces in customary measurement, which is 25 fluid ounces. And in milliliters, it's 739 milliliters. If you can see that, which is just shy of a full liter. Okay, a couple hundred milliliters shy of a full liter. The next one is It's actually a gift from one of my former students. I really liked gritty. I still like gritty. So this is like gritty sauce. It's like a wing sauce as well. And you probably can imagine that this here, it's like a sriracha. This here, I'm looking for the measurement, how many milliliters this is. Would you believe it's not labeled? In any event, it's probably about 250, 300 milliliters. Clearly smaller than the first one. And the last object I have is a container of milk. You can probably guess how big this is just by looking at it. So this is a gallon of milk, which is 3.78 liters. All right, all liquid measurements. So we're going to hop back over to the Smart file here, and we're looking at this container again. This is 1 liter. So this is about a third the size of the gallon of milk I had, and slightly larger than the Frank's Red Hot sauce. So think comparatively to the objects that you just brought and took a look at, examined the side labels, hopefully, and determined, just about how many milliliters they were, and give yourself a frame of reference for how big this pitcher is to your object. Is it a little bit bigger, a little bit smaller? So this pitcher holds 1 liter of liquid. The volume of liquid in the pitcher is 1 liter. The pitcher can hold more than 1 liter of liquid. The capacity of the pitcher is more than 1 liter. So you think of capacity and volume and the connection between the two. If you look at this empty space here, it has the capacity to actually hold more. All right, so it could actually hold more liquid. But if you want to get an accurate measurement, you're going to stop at this line right here, which indicates it's 1,000 milliliters. So 1,000 of these little lines, see these little dots here? 1,000 of them, which is equal to 1 liter. Think back to King Henry died by drinking chocolate milk. Think back to that poem and that song, and make those connections between milliliters to liters. So if you're converting, let's do King, kilo, hecta, Henry, die, deca, by is the base. In this case, the base is liters. Oh, it should be an L. Deci, centi, milli. And you're going from milliliters to liters. It would go 1, 2, 3 this way. So the decimal goes 1, 2, 3. So 1,000 milliliters equals 1 liter. So there's 1,000 little droplets, 1,000 droplets, milliliters of apple juice in here. But when you put them all together, you get 1 giant liter. Let's look at the next slide. Okay, so can you identify each figure? You've got 4 figures here. Can you identify them? Go ahead and take 30 seconds to write down your answers for 1 through 4. There's 1 and 2. And 3 and 4. What were the name of those figures? Stop right there if you need another second or 30. And here's the reveal. Number 1 is a cylinder. 2 is a cone. 3, sphere. 4, cone again, just upside down. Remember, when you juxtapose, when you change the position of a figure, it doesn't change what it is, right? All right. So here's another slide. The whole King Henry might help you again. Kilo, There's something wrong with my pen right here. Let me switch out of this. Let me switch to a different pen. Let me grab this one here. King Henry died by drinking chocolate milk. This is not true. That's not how King Henry died. This is just an acronym to help us remember kilo, hecto, deca, base, deci, centi, milli. And the bases are either liters, meters, or grams typically. Now remember, liters, kids, are for liquid measurement. Meters is measuring distance or linear spaces. And grams usually typically have to do with weight. So how many grams of cereal are in a serving, right? That's grams. Meters. How many meters of fencing do you need to enclose your yard? Liters. How many liters of water do you put into a batter of pancake to make the mix the right viscosity? All right, so liters is liquid, meters is linear, and grams is weight. Let's look at this first one here. 6 liters is how many milliliters? So if the base unit, in this case, I'm going to grab a new color, is liters, okay? I'm starting at 6 liters, so I'm starting here, and I'm going to milliliters, which is a smaller unit of measurement. So I'm going to go 1, 2, 3. What's this answer going to be? Let me give you a few seconds to jot it down, and then I'll reveal. Okay, hopefully you paused it and you came up with 6,000 liters, because the decimal, as I showed you up here in this diagram, in this acronym, it moved 1, 2, 3 places to the right. Let's hop over here to number 6, and I'll try to clear this. Pardon me. Try to clear this up a little bit. Go ahead, start looking at number 6 as I try to clean this part up. All right. All right, so 5,000 milliliters. So we're still talking liquid measurement. All right, so I can use the same base. All right, we're talking liquid because it says milliliters. Notice they do a lowercase m, capital L, and we're going to liters. So we're going from a smaller unit to the bigger unit. So we're going to start here, our decimal point. So if the number is 5,000, right? In the number 5,000, I'll grab yellow. The decimal point is here. And we're going to go 1, 2, 3 back to liters, because this is our goal, to go to liters. So decimal point will do that. 1, 2, 3. So go ahead and put your answer down, and I'll reveal in a second. Hopefully you figured it out. Yikes. 5 liters. 5,000 milliliters is 5 liters. This is review. All right. We did this, I think it was chapter 8, maybe. All right, let's look at number 7. So 2,019 milliliters is how many liters, how many milliliters? So 2,019 milliliters, just based on what we did up here, if 6 liters is 6,000 milliliters and 5,000 milliliters is 5 liters, then we know that 2,000 milliliters is going to be 2 liters. And then how many milliliters are left? 19. All right. And for this one, just think of when you're in the thousands, your thousands is going to be your whole number. So this is going to be 1 liter and 268 milliliters. Okay. All right. The capacity of a pitcher is 8 liters. The pitcher is filled to the brim with water. Find the volume of water in the pitcher in milliliters. I'm going to suggest I pause it. You pause it right here, and you go ahead and solve that. Okay. Hopefully you did the same thing. Maybe you even drew the King Henry died by drinking chocolate milk thing that may help you here, this little graphic organizer. And you did the same thing we did in number 5 and number 6. So 8,000 milliliters. The next one, a fuel tank of a car is half full. The volume of the fuel tank is 25 liters. Find the capacity of the tank. Well, let's break that down. Read a little, do a little. Let's reread that first sentence. The fuel tank of the car is half full. All right, so if I did my draw and I just make this the tank, maybe I'll go 3D. Now, cars' fuel tanks are not rectangular prisms. All right, but you can probably hear my kids fighting in the background. Sorry about that. All right. And fuel is not really blue, but so imagine there's your fuel tank. I think I filled that a little too high. It's only supposed to be halfway. Somewhere maybe in here. All right. Take a little fuel out. All right, so there's your fuel tank in the car. There's your draw. It's half full. The volume of the tank is 25 liters. So the next step, you might be like wanting to label here, and you would do 25 L, 25 liters. And I would underline that. Show your teacher what you know. Find the capacity of the tank. So there's the key word there for capacity. There's your find. You want to find if this tank were completely full, what would be the capacity of the tank? Well, if 25 is half, the other half would also be 25 liters. So to get the pen is not cooperating. I'm going to go back. The highlighter rather is not cooperating. To get your full capacity of the tank, you could do that a couple ways. You could add these two together. You can multiply, show your math to your teacher. 25 times 2 is 50. Label it, liters, and then, of course, you'd write a sentence. Let's see if we were right. 50 liters. So there you have it. In addition to this guided review kind of warm up to chapter 14, I'm going to put in some Khan Academy practice to reinforce what we talked about here today, and other activities to kind of help you set the stage for chapter 14. Thanks for your time and attention today. Keep up the great work.